Today we're going to take a look at equations using logs. So the first thing we're going to look at is solving equations using logs on one side. So if we take a look at this, our first problem is 3 to the power of x equals 1. And so we solved these when we talked about exponents, but we talked about making the base the same. For example, we solved something that was like 3 to the x equals 27 to the 2x. And we talked about making bases the same. So 3 to the x equals 3 to the third to the, let's switch this to, so this works, 27 to the x plus 1. So this was to the x plus 1. So then we said 3 to the x equals 3 to the x plus 3. So we said, 3x plus 3. So we said x equals 3x plus 3, and we solved. But you'll notice on this one we can't make bases the same. So we're going to go back and forth between exponential and logarithmic form. So as a log, this would be, we're solving for our exponent. So x equals log base 3 of 11. And then this would be a calculator question. So we can go to our calculator and control log base 3 of 11, and we have our answer of 2.18. So we can take a look at number 2 here, and again we can't make bases the same, so we're going to solve for our exponent. So x plus 1 equals log base 2 of 5 minus 1 minus 1. So x equals log base 2 of 5 minus 1. And remember that this stays together. This is a number on its own. So we just have to go to our calculator here and control log base 2 of 5 minus 1, and we have 1.32. So the next one that we are going to take a look at here is 6 to the power of 3x equals 81. So once again, let's solve for our exponent. So 3x equals log base 6 of 81. Divide by 3, divide by 3. So x equals log base 6 of 81 divided by 3. And again, this is a calculator one. So fraction log base 3 of 81 divided by 3. Log base 6. I knew something seemed a little weird there, too many 3's. So we have 0.817. Alright, so next we're going to take a look at a couple that get a little bit more complicated, solving equations using logs on two sides, because you'll notice there's a variable on both sides in the exponent here, which is different from the other ones. So we're going to start this by taking the log of each side. 5 to the x minus 1 log of 2 to the x. And this is nice because we can bring that exponent out in front. So x minus 1 log 5 equals x log 2. And now it solves the same properties as just solving an equation, except it's a little messier because of these logs. So if we distribute x log 5 minus 1 log 5 equals x log 2. Well, when you solve an equation, you want to get x's on the same side. So minus x log 5 minus x log 5. So we have negative 1 log 5, or negative log 5 equals x log 2 minus x log 5. And so now we have to factor out an x on this side. So x log 2 minus log 5, negative log 5. And we could simplify this. We know subtraction goes back to division. So x log 2/5 and divide each side by log of 2/5. So let's see, we go to our calculator on that one. Fraction, so log 5, but this one was negative, divided by, I don't know if I can just write it in. I'm not sure if that's going to work. I better use the log key. Log of 2/5, and we have 1.75. And again, we can always double check this. So we could go back to our equation and say 5 to the power of -1. Does that equal 2 to the power of that same thing? And it does, so we definitely have the answer there. So the next one, we're going to take a look at another one with logs on both sides, but let's switch this one to 2 to the power of x minus 1. So again, we're going to log both sides. So log 3 to the x plus 2 equals log 2 to the x minus 1. So exponents out in front, x plus 2 log 3 equals x minus 1 log 2. We can do some distributing, so x log 3 plus 2 log 3, x log 2 minus log 2. So now we have to get x's on one side. So I'm going to subtract this x log 2. But then I'm going to move the non-x's to the other side, so minus 2 log 3. So on this side, and we can't combine those, so it's x log 3 minus x log 2 equals negative log 2 minus 2 log 3. And then we have to factor out an x. So x log 3 minus log 2 equals negative log 2 minus 2 log 3. And you could condense this stuff, or we can leave it the same. So we have to divide by log 3 minus log 2 divided by log 3 minus log 2. And again, we can condense this, or we can type it in just like that. So we got our fraction key, negative log 2 minus 2 log 3 divided by log, 3 minus log 2. So we have negative 7.128. And again, we can go back up and we can plug this in. So does 3 to the power of x minus 2, does that equal 2 to the power of x minus 1? And something messed up. 2 to the power of x minus 1. And it looks like fairly close. I wonder if something rounded here, but let's check our work here. Let's see what we did. So we brought our exponents out in front. Looks good. I must have typed something in wrong there. Minus log 2. Must have typed something into the calculator wrong. I think I forgot a negative somewhere. Minus 2. Well, that's looking good. I wonder why it didn't give us the same answer. I mean, they're close, so I wonder if some of the rounding got a little bit off. That's what I'm guessing here. But anyways, I'll take a look at that again, see what we can figure out, but let's take a look at the last ones. We're going to solve with natural logs. So what natural logs are is, we've talked about the common log. If it doesn't show up, it's base e. There's also, or base 10, there's also a number called e in mathematics that shows up a lot. So if you have something that's log base e of 5, you'll never see it log base e. You'll see it as what's called the natural log of 5. So natural log is a log base e. So you'll solve them very similarly. So e to the x equals 1.53. So if we solve for our exponent and turn this into a log, x equals log base e of 1.53. This part right here, log base e, that's written as the ln, so the natural log of 1.53. And that key on your calculator is under that e to the x, so the natural log of 1.53. So 0.4252. You might say, well, why can't I say log base e? Well, you can. So you could do log, and then here's your e key, but you'll notice you'd have to put the power of 1 of 1.53, and we'll end up with that same answer. So the second one we're going to look at, we need to solve for x. So it's not in an exponent at this time, so let's see, get that log by itself. So let's see, we got 6.5 divided by negative 16.25. So we have negative 0.4 equals ln of x. And to rewrite this as an exponent, sometimes you might want to write this as log base e of x, negative 0.4, because then it's a little easier to see our base. So e to the negative 0.4 equals x. And again, this is a calculator one, so control, let's see. So here's e to the negative 0.4, and we have 0.6703. So the very last one we're going to take a look at, it's going to, the natural log, another one. So again, let's write this as log base e of x equals 2.3. So this would be e to the 2.3 equals x. And I'll leave that for you to type in your calculator, because I want to make sure we get to this last one. Find the inverse. So inverse, we switch x and y. So x equals 1/3 e to the 2y, excuse me. Well, we need to solve for y. So let's see. Well, let's hit 1/3. So if we multiply by 3, so now we have 3x equals e to the 2y. And now we could rewrite it. We're solving for we want to solve for y. So 2y equals log base e of 3x. So this is the ln of 3x equals 2y. Then we'd have to divide by 2. So y equals the natural log of 3x divided by 2. We could rewrite that is our inverse.